Localized regions of hypervariable sequence form the antigen-binding site. The V regions of any given antibody molecule differ from those of every other. The sequence variability is not, however, distributed evenly throughout the V regions, but is concentrated in certain segments of the V region. The distribution of variable amino acids can be seen clearly in what is termed a variability plot, in which the amino acid sequences of many different antibody V regions are compared. Three segments of particular variability can be identified in both the variable heavy and the variable light domains. They are designated hypervariable regions and are denoted HV1, HV2, and HV3. In the light chains, these are roughly from residues 28 to 35, from 49 to 59, and from 92 to 103, respectively. The most variable part of the domain is in the HV3 region. The regions between the hypervariable regions, which comprise the rest of the V domain, show less variability and are termed the framework regions. There are 4 such regions in each V domain, designated FR1, FR2, FR3, and FR4. The framework regions form the beta sheets that provide the structural framework of the domain, whereas the hypervariable sequences correspond to 3 loops at the outer edge of the beta barrel, which are juxtaposed in the folded domain. Thus, not only is sequence diversity concentrated in particular parts of the V domain, but it is localized to a particular region on the surface of the molecule. When the variable heavy and the variable light domains are paired in the antibody molecule, the hypervariable loops from each domain are brought together, creating a single hypervariable site at the tip of each arm of the molecule. This is the binding site for antigen, the antigen-binding site or the antibody-combining site. The 3 hypervariable loops determine antigen specificity by forming a surface complementary to the antigen, and are more commonly termed the complementarity determining regions, or CDRs, because CDRs from both variable heavy and variable light domains contribute to the antigen binding site. It is the combination of the heavy and the light chain, and not either alone, that determines the final antigen specificity. Thus, one way in which the immune system is able to generate antibodies of different specificities is by generating different combinations of heavy and light chain V regions. And that's localized regions of hypervariable sequence form the antigen binding site. Have a great day.